Hi, good morning. Welcome to ETESTCON. This is Kashif Hussain, Field Application Engineer. After having a brief keynote by Dr. Krishna Navluri, we are starting our first session of ETESTCON, an initiative of Menlopark Technologies. This session is presented to you by Dr. Roberto Bagnara, who will be presenting on MISRA C standards. This session will enable you to understand how Buxing's powerful tool, Eclair, will help you in achieving MISRA compliance for legacy and third-party code. It is well known that the greatest benefit of adoption of MISRA coding standards are when they are adopted at the very beginning of the project. In fact, imposing the MISRA guidelines upon an existing code base with a proven track record may be counterintuitive if not done properly. In this session, Dr. Bagnara will go through the provisions of MISRA Compliance 2020 document, achieving compliance with MISRA Coding Guidelines that specifically addresses adopted code, that is, legacy code, third-party libraries, device drivers, middlewares, and more. Finally, Roberto will present effective strategies to achieve MISRA compliance for projects. The amount of adopted code is substantial. I'm sure Dr. Krishna would have briefed about Menlopark Technologies in his keynote session. But for those who have joined just now, a quick overview of what we do. Menlopark Technologies is a leading provider of design, development, and testing tools to device software manufacturers across automotive, aerospace, and industrial automation customers around the globe. Menlopark Technologies provides certifiable product support and technology-driven training as a value addition. Now, coming to the speaker, a very good friend of mine, he's Dr. Roberto Bagnara, the Chief Technical Officer and Chief Scientist at Buxing. Roberto leads the team who designed and architected the Eclair software verification platform. Dr. Roberto is a full professor of computer science at University of Parma, Italy. He co-authored more than 40 papers in international journals and conference proceedings on programming languages, static analysis, and other MISRA techniques for software verification. He is also a member of the MISRA C working group.
Welcome to this session about MISRA compliance and legacy third-party code. Here is a brief outline of this presentation. First, I will introduce what is adopted code. I will have to do a quick recap on deviations because this of deviation is a very important concept in MISRA compliance. And then I will talk about how special it is adopted code with respect to MISRA compliance. I will then suggest tactics for dealing with adopted code. I will present 3 tactics and then I will draw some conclusion. So let's start with adopted code. The reference document for this presentation is called MISRA Compliance 2020. It's an official document issued by MISRA that defines what must be covered when making a claim of MISRA compliance. MISRA Compliance 2020 is applicable to MISRA C 2012, all revisions of it, and to MISRA C++ 2008. For the time being, adoption of MISRA Compliance 2020 is optional, but it will become mandatory for the next editions of both MISRA C and MISRA C++. And Chapter 6 in MISRA Compliance 2020 has to do with adopted code, and it is where the material for this webinar has been taken. So adopted code is typically derived from the standard library, which is usually shipped along with the compiler, from device drivers that are usually provided by the hardware manufacturer, middleware components such as operating systems, real-time frameworks, and protocol stacks, third-party libraries such as mathematical or graphic libraries, automatically generated code, that is, code generated by modeling tools, and legacy code, code developed for other projects or previous versions of the current project. And all code that is not adopted is called native code. Now, the bottom line on adopted code is that even if you have it, safety and security of the overall system should not be compromised. Someone thinks that you can simply ignore adopted code. This is not true. Here is an excerpt from MISRA Compliance 2020, and it says that the impact of adopted code on the integrity of a system must never be overlooked or assumed to be benign. There are two distinct issues to consider: the adopted code being developed to a verifiably adequate level of safety and security, and as the adopted code being developed to be compliant with MISRA guidelines. And these two issues are not equivalent. Compliance with the MISRA guidelines is neither a necessary nor a sufficient condition to ensure the quality of adopted code. So when does it make sense to consider code adopted? It only makes sense if it is existing code with a proven track record, if it has been assessed to be fit for purpose, so it does exactly what you need, and the risk involved in changing this code outweighs the risk of leaving it as it is, so you don't want to change it. And notice that adapted is different from adopted. So code adapted from a previously developed code is not adopted by default. It should be considered a native code. And the rule of thumb in order to decide whether the code can be considered as adopted or not is this: if you can consider it adopted if you have good reasons for not wanting to change it. So let us go ahead by recalling what are deviations. The deviation process is the procedure by which justifiable non-compliances can be authorized and recorded. And the exact process is not imposed by MISRA Compliance 2020 because the methods can vary between organizations. However, MISRA Compliance 2020 does impose some constraints on the process. So the deviation from MISRA guideline must not be permitted simply to satisfy the convenience of the developer. So it's inconvenient is not a good reason. And deviation must not be permitted when there are reasonable alternatives to write the code so that a violation is unnecessary. You cannot deviate without considering the wider consequences of a particular violation on other guidelines, or without the support of a suitable process, or without the authorization of a designated technical authority. And in particular, a proposed deviation should only be approved if it can be justified on the basis of one or more of the following: code quality, access to hardware, adopted code integration, and non-compliant adopted code. As you can see, 2 out of 4 reasons that are legitimate for approving a deviation from the MISRA guidelines have to do with adopted code. So let us move to the section where we describe how adopted code is special with respect to MISRA compliance, how it makes sense to consider it special. So first thing to understand is this, that at the outset of the project, the acquirer and supplier of the software shall agree upon one or more guideline recategorization plans. So a guideline recategorization plan is a remapping of the category of the guidelines. There are constraints, of course, and for example, a mandatory guideline can only be left untouched. So mandatory means mandatory and it cannot be remapped. However, a required guideline may be upgraded to mandatory, and an advisory guideline may be upgraded to required or mandatory. Advisory guidelines may also be downgraded to disapplied, as we will see. This can be done, in particular, in presence of adopted code, when it is arguable that there is no value in enforcing a certain advisory guideline. In the presence of adopted code, it makes a lot of sense to use multiple guideline recategorization plans, one for the native code and one or more for different portions of the adopted code. I can anticipate that one of the tactics I will suggest will be to, for example, disapply all the advisory guidelines that adopted code does not respect. Okay, so this is why you would want to have multiple GRPs in the same project to treat different portions of adopted code specially. It is important to understand one thing. There are several guidelines in the MISRA coding standard, both MISRA C and MISRA C++, that have a system-wide analysis scope. So that checking the rules involves checking more than one translation unit, and the compliance depends on the relationship between these translation units. Well, for these rules, for these guidelines, it may happen that the combination of compliant translation units is non-compliant. Well, if all the involved translation units are in native code, then the violation can be solved with appropriate modifications of the code. However, when some of the translation units are in adopted code, then raising a deviation may be necessary because, as I have said, and as I will repeat, you normally don't want to change adopted code. And the reason to be given for this deviation is adopted code integration. So this is what it means. Okay, adopted code integration means I have to deviate because I am integrating adopted code with native code. Okay, and there is a technical counterpart to this reasoning. In order to work effectively on projects with adopted code, then you need a sophisticated static analysis tool, a sophisticated analysis tool that has high configurability. We will see an example soon. Okay, there is in MISRA Compliance 2020, there are also provisions concerning adopted binary code. Binary code is a problem for MISRA compliance, of course, because the MISRA guidelines apply to the source code. So when adopted code is only available in binary form, then MISRA compliance is not fully verifiable by the acquirer. You can save the day if the supplier is willing to issue a statement of MISRA compliance. But if this is not the case, then and you have adopted binary code, MISRA compliance cannot be achieved, and you have to look for other avenues to ensure that the quality standards are maintained. Okay. Then, when the adopted code is provided in source form, things are, of course, different. And the point is that violations in adopted source code cannot be simply ignored, as many people believe. Every guideline violation needs to be reviewed. And as changes in adopted code have to be avoided as much as possible, okay, suitably justified deviation will have to be raised, still in the hope that no mandatory guidelines are violated, because as we said before, mandatory guidelines cannot be deviated. They must be observed at all times. So we will go through some possible tactics of dealing with adopted code in the second part of this presentation. Now, let me present an example about the integration of adopted code and native code. So there is a very common case in which the adopted code header files are included in native code modules, and this poses additional problems. For example, there is a rule. We will meet this rule again in this presentation. It's rule 11.9, of MISRA C 2012, and it says that in order to verify whether a pointer is null or not, you have to compare it with the macro null, all capital letters. So in this example, we see that a macro called isNull in adopted code is used by native code to test whether a pointer is null or not. Okay, so this is a violation of rule 11.9 because due to macro expansion, we will end up with a comparison of a pointer with the integer constant 0 and not with the macro null. So there is nothing wrong in the macro is null per se. Okay, the point is that the macro is null should not be used to on pointers. So it's the problem is that the use that is made of this macro in the native code. So and the situation can be more complex because the macro is null will typically be used both in adopted code. You see that is null is the same macro we have seen before, and is null is used in adopted code, which is something that we would want to permit because, as I said, adopted code is code that works, and it is code that we don't want to modify because it has an history of use that, or there are other elements that guarantee for the quality of such code. And isNull is also used in native code. So you see that this invocation of isNull, which is in the adopted code, should be permitted, whereas this one, which is in native code, should not be permitted. Okay, and to do this, you need your static analysis tool to be configurable enough to express this thing. MISRA C 2012 rule 11.9 is deviated in expansions of the macro isNull when directly invoked in adopted code. So this is okay, which implies that the rule is not deviated in expansions of the macro when directly invoked in native code. So this invocation is not okay. An example for the Eclair static analysis tool of configuration that achieves this result is this. First, we apply the tag adopted to the file named adopted2.h. This is, in fact, the name of this header file. And then we write the configuration for MISRA C 2012 revision 1, rule 11.9, saying that all reports against this rule that are such that the expander of the macro is null is adopted code, this should be hidden. Okay, and other expansions instead will not be hidden. As we have seen in the introductory part, the standard library is part of adopted code, but it is special. It's special because the C standard library is an integral part of the language implementation. And it is very often the case that its implementation, including the header files, rely on implementation defined, unspecified, and sometimes also undefined behaviors of the language. However, this is fine because we can assume that the compiler implementer has taken all of these aspects into consideration as the standard library and the compiler are usually developed at the same time. There is a strong integration between the two. So MISRA recognizes this state of affairs, and so in all adopted code, the standard library is special in the sense that, differently from all other categories of adopted code, the standard library needs not to comply with the MISRA guideline. So it is not true that you can ignore the MISRA guidelines for all adopted code, but it is true that you can ignore the MISRA guidelines on the standard library, which is part of the adopted code. Now let us move to the tactics for dealing with adopted code. So tactic 1, exchange mandatory with required or advisory. This might be surprising at first sight because I've said that mandatory guidelines are non-negotiable, so they cannot be remapped to required or advisory. However, as I will show, it is possible to avoid the violation of a mandatory guideline by accepting a violation of a required or advisory guidelines. And this is something that can save the day when your adopted code violates some mandatory guidelines. Tactic number 2 is exploit through adoption. I will explain this in detail. Tactic number 3, I've already announced it, is disapply violated advisory guidelines. So let's start with the first tactic. As I said, when a mandatory guideline is violated, it may be a disaster. So if it is a false positive of the tool, we have to prove it, and otherwise we need to change the code. However, we have said that we do not want to change adopted code because adopted code has a proven track record, and by changing it, we risk introducing bugs. Okay. However, in this case, if mandatory guidelines are violated, we will have to compromise. Changes will have to be minimal and be accompanied by adequate guarantees. And in some cases, the elimination of a violation of a mandatory will cause the introduction of violation for required and or advisory guidelines. However, we can deviate those, so we have gained something. Let me present this with an example. The example is based on rule 9.1, saying that the value of an object with automatic storage duration should not be read before it has been set. It's a mandatory guideline, and it is mandatory precisely because while static storage variables are automatically initialized to 0, unless they are initialized explicitly, objects with automatic storage duration, so variables on the stack, are not automatically initialized and can have, until they are written, indeterminate values. And an attempt to read an object with an indeterminate value is undefined behavior. So this is why the rule is mandatory, because it is directly tied to an undefined behavior. Let's see an example. So suppose we have this in adopted code. We have a declaration for variable x, which is not immediately initialized. We have lots of code here, and then the tool here is warning us that the variable x may be read by the return statement while still initialized. So there are several possibilities. For example, you can prove it is a false positive, and you will have just to record your argument in the guideline compliance summary. So in the final report where you write all the evidence that proves MISRA compliance. Okay. If you cannot prove it is a false positive, then you will have to change the code because it is mandatory. Okay. So as the initializer value can be returned untouched in this code, the choice of the initializer must be thoughtful. So you cannot just use any initializer. So here I am writing in the example, I am initializing the variable with 0 after careful consideration. And by adding this initializer, what may happen is that now the tool might flag this initialization as a possible violation of rule 2.2. That is a rule saying that you shouldn't have bad code. Bad code is code that you can remove without changing the semantics of the program. However, rule 2.2 can be deviated. Okay, so if this new initializer we have added to the code is flagged by rule 2.2, we will simply have to deviate the rule for this specific case. Notice that if our analysis does not allow you to be 100% sure about the fact that the initializer is correct, so here I have added a 0 initialization, we have to use other kind of precautions. Here is another example, assuming that the value int32 min is not possible for the variable x in this function. I can use this as an initializer, and then at the end of the original code, if I still find this value int32 min in x, then I know that this was initialized before I added this initializer. So then here I will apply countermeasures, okay, if necessary. Notice that there are violations of rule 9.1, which you really have to change the code. So no matter what. For example, this self-initialization. So where you initialize variable x with itself, it's undefined behavior. So the way to deal with this is to remove this bogus self-initialization and proceed as in the previous example. Okay, this was the first tactic, exchange mandatory with required or advisory, which is the only hope we have when we have a violation of a mandatory in adopted code. Then tactic number 2 is exploit through adoption. So through adoption means if we have legitimately flagged this code as adopted, it means that it is existing code with a proven track record, so it works. That it has been assessed to be fit for purpose, so it does exactly what we want, and the risks involved in changing it outweigh the risk of leaving it as it is, so you don't want to change it. Okay, so this implies that the code works as intended. Second, we need not understand its implementation, just its interface. And third, we will not change it in ways that can impact its integrity. And these are a good rationale for possible deviations. Let us start with an example concerning rule 2.1. A project shall not contain unreachable code. This is a required rule. The point is that legacy third-party code may have been designed to be built for different configurations. Okay, so think about a library, for example. Okay, and in this case, the fact that some code is unreachable is not an indication of a programming error. And the rationale for this MISRA rule is that unreachable code may constitute the evidence of a programming error. So this is not the case for adopted code, especially if it has been designed to be built for different configurations. And of course, your rationale for deviating this rule for adopted code is stronger if the linker is such that, for example, it will remove unreachable functions at link time. So in this case, the code is unreachable, but the linker will not include the code in the final executable. So part of the risks involved in having unreachable code are mitigated in this way. Let us consider rule 5.3. An identifier declared in an inner scope shall not hide an identifier declared in an outer scope. So this is to avoid the potential confusion. So when this effect, which is called shadowing, happens, it happens when a declaration in an inner scope has the same name of a declaration in an outer scope. So the inner one hides the outer one, and the programmer might be confused about which one is being referred. However, this risk is not present in adopted code because, as I said, adopted code is not meant to be read, reviewed, or modified by human programmers. So there is no possibility of developer confusion, and this is a good rationale to deviate Rule 5.3 in adopted code. In this presentation, I only show some examples. There are many more rules in MISRA C and MISRA C++ that have to do with developer confusion, and all of them can be deviated along these lines. Another example, which is very similar, is Rule 7.1. So octal constants shall not be used. The reason is that octal constants are increasingly less used, so programmers more and more don't know about them, so they might even use them inadvertently, and so this is a risk, but it is not a risk in adopted code, because again, adopted code is not meant to be read, reviewed, or modified by anyone. 7.2 is very similar. A U or capital U suffix should be applied to all integer constants that are represented in an unsigned type. This rule is there because the type and signedness of a constant integer is a potential source of confusion, because whether it is signed or unsigned depends on a complex combination of factors, which include how large the constant is, the size of the integer types in that implementation of the language, the number base used, and the presence of any suffixes in the literal. But again, since we are talking about adopted code, the risk of developer confusion is not there. Rule 8.4 is more complicated because it's not just about developer confusion. This can result into real undefined behaviors, for example. It says a compatible declaration shall be visible when an object or function with external linkage is defined. So the incompatibility between declaration and definition is undefined behavior. And Rule 8.4, along with 8.5, this pair of rules in MISRA C 2012 provide a very convenient way to avoid this risk by always allowing the compiler to check the compatibility. For adopted code, this rule can be deviated. However, a requirement is that we have other ways to ensure that we have compatibility between declarations and definition. Once this is done, we can safely deviate Rule 8.4 when one or more adopted translation units are involved. Rule 10 is a rule that has to do with essential type model of MISRA C. This is a section comprising several rules. There are several of them that have to do with developer confusion. So these are rules 10.2, 10.5, 10.6, 10.7, and 10.8. They have all to do with developer confusion. So this can be deviated without further consideration when they affect adopted code. However, in this same series, there are other three rules, 10.1, 10.3, and 10.4, that also involve undefined, unspecified, and implementation-defined behaviors. Of course, these have to be ruled out before deviating. Here is Rule 11.9, which we have already mentioned. The rule saying that the macro null shall be the only permitted form of integer null pointer constant. Again, this is about developer confusion. Using null makes it very clear that we are talking about a null pointer constant and not an integer. So in adopted code, we can deviate because no developer confusion is possible. The rule 16, the rules in the series 16 have to do with the switch statement, and these have restrict the use of the very liberal syntax for the switch statement. Some of you will have heard about this DAF device, which is a very surprising use of the switch statement in C. And the rationale for these rules, for all of them, is developer confusion. Again, we can deviate the entire series in adopted code because no developer confusion is possible. Tactic 3, disapply violated advisory guidelines. So if we adopt MISRA Compliance 2020, we can disapply advisory guidelines. We just have to give rationale for this application. However, the rationale covers the case where there is no point in checking advisory guidelines on code that was not written to respect them. And this is typically the case for adopted code. Of course, there is no point in disapplying advisory guidelines such that the adopted code happens to comply with. So if the code is in compliance, why disapplying them? You disapply only those that are violated by the adopted code. Okay. In the guideline recategorization plans, you will have to justify the disapplication of advisory guidelines, but the justification will be very simple in the case of adopted code. So it's just the fact that it is adopted code that alone means that there is no point in applying them, only to verify that there are violations. So time to conclude, but before concluding, let me stress that staff competence is a crucial requirement in order to carry out activities that allow classifying a project as MISRA compliant. The several functional safety standards put requirements on the skill of the software team members, including the user of static analysis tools. For projects where adopted code is used, MISRA and tool competence is even more important, okay, as I have very briefly touched in this presentation. Without a proper understanding of the MISRA guidelines and of the process of which they are an integral part, you may end up with a completely flawed MISRA compliance agreement, MISRA compliance argument, and this may violate the agreement which you have signed with the acquirer if you are a supplier of presumably MISRA compliant code. Management of adopted code is one of the areas in which the consulting services of Bagsang may save you a lot of time and effort. So, conclusion, we have addressed the topic of MISRA compliance. As far as adopted code is concerned, there are several messages to take home. There are requirements on adopted code. So, several people believe that you can simply disregard adopted code. This is not the case. Second point to take home is violations of MISRA guidelines in adopted code cannot be ignored, apart from the standard libraries. And third point, there are tactics that may help you a lot in order to deal with adopted code. We provided 3 of them. However, the management of adopted code may still require a lot of energies. Proper training and good tools are even more important when adopted code is present. And this is an area where consultancy services can be recommended. That's all for now. If you have questions, I will be happy to answer them.
Thank you, Roberto, for showing us how to achieve MISRA compliance for legacy and third-party code. For the delegates who have questions, you can post it in the chat box. Roberto will answer them now. Alternatively, you can also write to us at support@menlopark.com.